Okay, we've got a projectile motion question here where it says that Aaron throws a ball to John with a velocity of 16 meters a second at an angle of 35 degrees above the horizontal. Assuming no air resistance, find A, the maximum height the ball will reach, and B, how far John is away from Aaron if he is able to catch the ball at the same height as it was thrown. Now, straight away, the first thing you've got to do when you get presented with a question like this is draw the problem out. So I've drawn this out earlier. We've got Aaron. We've got John. And so Aaron throws the ball to John at an angle of 35 degrees and at a speed of 16 meters a second. Okay, now to start with, we have to find A, the maximum height the ball reached. So we've got to find where this point is here. So the first thing we're going to have to do is we're going to have to break this initial velocity into its components, its vertical component and its horizontal component. So to do that, what we're going to do is we're going to draw a triangle, like so. Okay, now we're going to use a little bit of trigonometry here. So here we have the horizontal component, which is going to be the flat part of this triangle. You can see that this triangle here is just a blow up of this triangle, or this release velocity and release angle that we've got over here. And the way we're going to work out the horizontal velocity, or VH, is we're going to get the initial velocity, and because this is the adjacent side, we're going to times it by the cosine of the angle. And that gives us 13.11 meters a second. Cool. And with the vertical velocity, or VV, because this is the opposite side to the angle, we're going to use the sine, or the sine of the angle. So we're going to go 16 sine 35 degrees. And that's going to equal 9.18 meters a second to the negative 1. Now, both of these values here obviously have been rounded. I just take them usually to 2 decimal places as a rule of thumb. If you're doing an exam, it'd probably be worthwhile just checking what sort of accuracy that the examiners like you to carry through problems. But for me, I'm just going to be using 2 decimal places. Okay, so from here, we can then use this horizontal velocity to find the maximum height the ball is going to reach. So we're looking for that point there. So what we're going to use is we're going to use the equation v squared equals u squared plus 2as. Okay, now hopefully you'll know that the capital V is the final velocity, u is the initial velocity, a is the acceleration, and s is the distance. Now, at the maximum height that we have here, the final velocity is 0. Now our initial velocity in the vertical direction is 9.18. And then we're going to go plus 2. Now the acceleration on this is the acceleration that's due to gravity. So we've got a gravity force coming down, and that's going to be, because it's in the opposite direction and it's a vector, we have to give it a minus sign. We're going to call the acceleration due to gravity 9.81 meters per second squared. times then s, which is the distance. Okay, now if we rearrange that and then just solve for s, I'm assuming that you can do the algebra to rearrange that. We get 4.295 meters. So, for the A part of the problem, that is our solution. You can write after it, you can write above the release height, if you like. Now, the B part of the question, it asks us, how far is John away from Aaron if he is able to catch the ball at the same height as it was thrown? Okay, for us to work this out, so we're looking for that distance there. Okay, so to start with though, what we're going to need to do is we're going to need to find the time that the ball is in the air for. Now, the reason we have to find the time is because although the horizontal or the vertical component, of the velocity changes because of the opposite acceleration due to gravity, the horizontal velocity is constant throughout the whole length of the ball's journey. So what we can do is if we can find the time that the ball is in the air, i.e. the time that it takes to come up and then go back down again, then what we'll be able to do is we'll be able to just use that time to figure out and then multiply it by the horizontal velocity to work out how far it actually goes in this direction. Cool. So what we're going to do, we're going to find the time. So the time, we're going to use the formula V is equal to U plus AT. Now, obviously, again, final velocity, initial velocity, acceleration, we're going to use the acceleration due to gravity, and the time. So we're going to just sub in our numbers. So 0 is equal to 9.18 plus negative 9.8 because it's in the opposite direction times time. And what this is going to tell us, the time that it takes the ball to get from here, throws it to get to its maximum height. So that's that time there. So time for this is equal to 0.936 seconds. Cool. So, because parabolic motion is symmetrical, i.e. the upward motion of the ball is equal to the downward motion of the ball, what's going to happen is the time that it takes to get from this point to this point is also going to be the time that it takes to get from this point back down to the ground again. So what we can do is, if this is t, this is also going to be t. So what we can actually do is we can just multiply the time that we get to the maximum height by 2, and that'll give us the total time. So we can, therefore 2t is equal to 1.872 seconds. Cool. And once we've done that, what we can then do is we can just use the simple formula distance is equal to velocity times time. And we'll just move this up to here. So then S will equal the horizontal velocity, which is 13.11, multiplied by the time, 1.872, and that's going to give us 24.54 meters. So that's what this is going to be equal to here. Cool. So basically what we've got there is this is our A, this is our B here. So for A, we were able to calculate, to start with, we calculated the components of the release velocity. So we calculated using trigonometry what the horizontal component and the vertical component was of the initial velocity. Using the vertical component and the fact that the final velocity is 0 at the maximum height, we were able to calculate the distance that the maximum height is from the release point, and we're able to get that as 4.295 meters. And then in B, we're able to calculate the time using the same sort of situation, that the final velocity at the maximum height is 0, and the initial velocity we calculated using trigonometry, and the acceleration due to gravity, we're able to calculate the time. We're able to use the fact that this is symmetrical, the motion is symmetrical, to find the total time, which is just 2 times the time from the release height to the maximum height. We're then able to use this, and it's the horizontal component of the velocity, which remains the same throughout the ball's motion, to calculate the final distance from the throw to the release. Okay, well, I hope that helped.